What if I told you that a mistake so small that you could barely see it could cost you millions of dollars? Not a wrong question, neither a computer crash, just a tiny mistake in a number. A single dot in the wrong place sounds impossible, right? Well, let me show you something strange. Look at these two prices, $0.002 and $0.002. At first glance, they seem almost identical. Most people would probably read them and move on without thinking twice. But here's the catch, they're not the same. In fact, one is 100 times smaller than the other. And if a company makes that mistake while calculating millions of transactions, the loss can be enormous. But why does such a tiny difference create such a huge problem? To answer that, we need to understand something surprisingly simple. Numbers don't have meaning by themselves. Imagine I tell you the answer is 50. What does that mean? 50 what? Is it 50 apples, 50 kilograms, or 50 years? Without context, the number 50 is almost useless. The meaning comes from the units attached to it. And this is where many mistakes begin. Let's take another example. Suppose a car travels 100 kilometers in 2 hours. Most of us can quickly calculate 100 divided by 2 equals 50. Pretty easy. But what have we actually found? Not just the number 50, we have found a speed, 50 kilometers per hour. The unit tells us what the answer means. Without them, the calculation is incomplete. Now let's talk about division itself. Most people learn that 12 divided by 3 equals 4. Simple enough. But have you ever thought about what division is actually doing? There are two ways to see it. First, sharing. If 12 candies are shared equally among 3 children, each child gets 4 candies. Second, measuring. How many groups of 3 candies can fit inside 12 candies? Again, the answer is 4. Same calculation but different interpretation. Because mathematics is not really about numbers, it's about meaning. Now, here's where the things get even more interesting. Our brains are surprisingly bad at judging very small numbers. Look at these, zero point zero 0.02, 0.002, and 0.0002. They look almost the same, just a few extra zeros, nothing special. But each number is 10 times smaller than the previous one. A tiny movement of the decimal point completely changes the value. And that's why scientists, engineers, pilots, and businesses are obsessed with precision. Because small looking mistakes are not really always the small mistakes. Sometimes they are enormous mistakes wearing a disguise. So let's go back to the question we started with. How can a mistake so tiny cost millions of dollars? Because numbers are more than the digits we see. Their true meaning comes from their units, their scale, and where the decimal point sits. A tiny dot may look insignificant, but in mathematics, that tiny dot can change everything.